Inverse functions. Tell me what you remember about inverse functions. Switch the x's and y's. So that is really the main focus that we use in Algebra 2, and it's absolutely a fact. Based on the skills that we know you have to do in Algebra 2, that's kind of the reason why we come at it from that vantage point. One of the more technical definitions is, and more proper definitions, I would say, is this first piece of information here. If f of g of x, when you compose the two functions, equals x, and the reverse order also has to be true, g of f of x has to equal x for all real numbers, then f of x and g of x are said to be inverses, because that whole, again, I know you focus on switching the x's and y's, but the whole idea of two functions that are inverses are functions that kind of reverse what the other one has just done to an input. So, you know, one of the examples I think of is, you know, as if factories work this way, but picture a machine that you threw some leather and some lace into, like lace, like, well, you'll see when it pops out. If you throw leather and lace into a machine, it does something to all of that, and then out pops a football, right? So there's a machine that's making footballs with those materials. So that would be the first function, the first machine. Then you take that football, whatever it came out as, that football, and you put it into the inverse machine, and it essentially just takes apart the football, and then out pops leather and lace again. Does that make sense? So whatever the first machine does to something, does to the materials, the other machine kind of undoes that in the reverse order. Yes? Same thing would be true with functions that are inverses. So if I were to try to determine whether or not these two were inverses, I would check f of g of x. That means I'm taking my g of x function and plugging it into my f function. So that would be 3. I'm taking out the x and replacing it with this quotient, plus 2. So when you distribute your 3, it cancels, and you're just left with x minus 2 plus 2, which is just x. Unfortunately, that can coincidentally happen in one direction, but not the other. Meaning it could coincidentally happen that f of g of x gives us x, but g of f of x will not. So this is why we have to do it in both directions to confirm yes or no. So now g of f of x means I take my f of x function, the 3x plus 2, and I plug it in for the x in the g of x function. So that would be 3x plus 2 minus 2 all over 3. So I'm replacing this x with 3x plus 2. Connor, are you with me? So we simplify the numerator, 3x plus 2 minus 2. The plus 2 minus 2 cancel. 3x divided by 3 is x. So this would be yes, and you had to prove it both ways. Just for kind of the sake of elaborating on that example, take a look at f of g of 5. So if I had 5, I would subtract 2 and then divide by 3. So 5 minus 2 is 3, divided by 3, out pops a 1. So then it would be f of 1. So remember the order in which what I did there. I subtracted the 2 first and then divided by 3. So now if I'm taking the 1 and I'm undoing that, reversing the order, remember I subtracted 2 and then divided by 3, the first thing I'm going to have to undo was that division by 3, hence the multiplication by 3 that's occurring first. And then I'm undoing the fact that I subtracted 2 by then adding 2 back. So if I plug 1 in, 3 times 1 is 3, plus 2 brings me back to 5. So f of g of 5 equals 5. What does f of g of 7 equal? 7. What does g of f of 11 equal? 11. Do we see that? So when you compose any number, any variable through the composition of inverses, you get the original back. Just a little bit of a different vantage point than you probably focused on last year. But that's the more technical definition. Okay, writing the inverse, which was a big skill in Algebra 2, this is where that whole switching the x's and the y's came in. Because we switched the x's and the y's, and I'm going to fly through this because I know you know how to do it. And we solve for y, so I subtract 1 from both sides. Now, I don't know how much you solved cubic functions last year, but how do you get rid of that cube? Good, cubed root of both sides. Now, when we take the square root of both sides, we need a plus or minus. Is that the same here? No, because the cubed root, you can take the cubed root of a negative, so you don't need to worry about that. And then why can that not be my final answer? What is my final answer, Liam? Yeah, f inverse of x is how we would say that. Yeah, just changing your notation. I don't love to the negative 1. I know that's what it looks like, but it is not an exponent. So I'm just going to be particular about that. I don't want people to think that that's an exponent. So you just read that f inverse of x, or the inverse of f of x, equals the cubed root of x minus 1. Okay? Now, visually, what's the relationship between a function and its inverse function? If I were to plot them both on the same